So nervous system can be broken down into the central nervous system and the peripheral nervous system. So come in here, central nervous system, peripheral nervous system. The peripheral nervous system is really just your somatic nervous system, and this is muscle movement, those kind of things, the things that we do consciously. We have to think about it. This is your conscious movement. It consists of one neuron, and it just synapses at the effector organ. So, right there, and we just put effector organ. The central nervous system, it has two different branches off of it. It has the sympathetic nervous system and the parasympathetic nervous system. So, the sympathetic nervous system, this is your fight or flight. This is the things that are life-threatening. So we'll put fight or flight. And the the parasympathetic nervous system, this is rest and digest. Rest plus digest. Okay. And because of this, they have very different things. Both have two neurons. So 2 neurons and 2 neurons. And the lengths of these neurons depend on where they're coming out. The sympathetic nervous system, it has neurons that come out of from T1 to L2. That's where those neurons come out of on the spinal cord. And the PNS, these are mainly your cranial nerves, and specifically a lot of them come off of the vagus nerve. So we're going to put cranial nerves. Alrighty. So we're going to take a little bit closer of a look here at the differences between the parasympathetic and the sympathetic nervous system. So, let's take a look first at the sympathetic nervous system. So the sympathetic nervous system, the SNS. All right, there are 3 different ways that the sympathetic nervous system can synapse. So if we have our little spinal cord right here with the horns. That's terrible drawing. That's good enough. So the first way that this sympathetic nervous system can synapse is we have a nerve comes out of the lateral horn and comes back behind the sympathetic chain ganglia and up into it and synapses in the sympathetic chain ganglia with another nerve, and that one goes up into the thoracic cavity. These are called your sympathetic nerves. Here is your sympathetic nerves. These, they innervate the thoracic cavity and everything that goes on in there. The next one that we can have is a nerve that comes out of the lateral horn. Again, you have the sympathetic chain ganglia. It can come out behind and then back up in and synapse. And then this second nerve can go out and join into the spinal nerves that go out to the rest of the body. And these will innervate your blood vessels. So this is specifically for blood vessels. All right. Then the third one that we can have happen is we will have ignore this, that looks horrible. Yeah, there we go. We'll have this come, we'll do it on this side. We'll have this come out, again, sympathetic chain ganglia. It comes out and behind, but it does not synapse in the chain ganglia. It comes out and it synapses in what's called the collateral ganglia. And from there, it'll go out, and these are called your splanchnic nerves. Splanchnic nerves, and they innervate the abdominal cavity. So this is anything below the diaphragm. These are your nerves that come off below the diaphragm. And the last thing that we can have happen is if we had another nerve that came off that comes through here. We'll just use this example because it's a splanchnic nerve. It just has a different function. If we have this nerve that comes through and it does not synapse at the collateral ganglia, it comes through and it synapses at the adrenal medulla, then the adrenal medulla would then release epinephrine into the bloodstream, and this is the fourth way we can have happen. It's a splanchnic nerve. It goes. The only difference is it does not synapse at the collateral ganglia. Now, the parasympathetic nervous system, it is a lot, I guess, simpler. It has the cranial nerves. We'll draw a little brain here with the spinal cord. They come off the cranium and they just come down, and they don't enter the spinal cord at all. They come right out of the brain and they come down, and they only innervate the cavities, the thoracic and the abdominal cavities. They don't go out, they don't do any peripheries or anything. They only do the cavities. And that makes them a lot simpler because they just synapse pretty much at the effector organs or right next to them. They're pretty close to the effector organs. Now, the difference between the sympathetic and parasympathetic nervous system are the type of receptors used. So, in all of the nervous system, the autonomic nervous system, parasympathetic and sympathetic, the first receptor we're going to get to is an N2 receptor, which is a nicotinic type 2 receptor. This is an ionotropic, cholinergic, right? Cholinergic receptor, which means it is a gated channel, a ligand gated channel. Here, the acetylcholine will come in and bind there, opening this gate, allowing ions to flow through and create the action potential in the next neuron. And those are on all of them. So it doesn't matter where that first nerve is synapsing, whether it's the sympathetic chain ganglia, the collateral ganglia, or the adrenal medulla, they're always going to have that N2 receptor. So the other main difference is the second receptor. So we have different types of receptors. For the sympathetic nervous system, we have our alpha 1s, our alpha 2s, our beta 1, our beta 2, and our beta 3. And for these, they have different effects. So alpha 1, that's going to increase IPO. First off, these are metabotropic, which means they use G proteins. So these are all metabotropic. They're all metabotropic. This one will increase IP3. And due to the increase of IP3, it's going to trigger an EPSP, which is an excitatory postsynaptic potential. And alpha 2, it does a decrease in CAMP, which does an IPSP. A beta 1 receptor does an increase in CAMP, which does an EPSP. And beta 2 is kind of special. Beta 2, it increases CAMP, so CAMP, but it causes an IPSP. That's where it's a little bit special. And then beta 3 is an increase in CAMP and causes an EPSP. And these are the type of receptors that are on the second, the effector organ. These are what the second neuron synapses with. And some important things is an alpha 1 receptor, it binds more tightly to norepinephrine. So it really likes norepinephrine. And these alphas and betas and the other receptors I'll get into in a minute, they all receive catecholamines. So you have your catecholamines, which are your dopamines, your epinephrine, and norepinephrine. And that's what will come in and bind to these receptors. We also have dopamine receptors, so D1 and D2. And D1, increase in CAMP, and it's an EPSP. And D2 is a decrease in CAMP, and it's an IPSP. So, these are what are called adrenergic receptors. That's the word, adrenergic receptors. Next, for the parasympathetic nervous system, for the PNS, we have, these are also all metabotropic. These are muscarinic receptors. So we have M1, M2, M3, M4, and M5. So M1, it causes an increase in IP3, which causes an EPSP. M2, decrease in CAMP, which causes an IPSP. M3, increase in IP3, EPSP. M4, decrease in CAMP, IPSP. And M5 is an increase in IP3, and it is an EPSP. And these receptors, they receive acetylcholine. So they receive ACH, acetylcholine. Now, why is this important? Well, this is important because different organs in the body, depending on what they're trying to do, have different receptors, such as your eyes. Your eyes, they have receptors that will either dilate or constrict. So you have these round muscles here, and you have your radial muscles coming off of it. The round muscles, they're going to be what we call an M-odd. M1, M3, M5, I think they're M3. M3 receptors. And these out here in the eye are going to be alpha 1 receptors. The lungs are beta 2 and M1. And then the heart, we're going to have beta 1 and M2. And then blood vessels, they're exclusively alpha 1 because, like I said, the parasympathetic nervous system does not go to extremity. It is strictly body cavity. So what does this mean? This means that in fight or flight, the sympathetic nervous system, the second receptor in that system is going to be alpha 1. Well, if we remember, alpha 1 is going to be an EPSP, which means these are going to contract and it's going to dilate those pupils, allowing you to see more. And when we're in rest and digest, we don't need to see as much. So these M3s, they also cause an EPSP, but they receive acetylcholine. So this means that the pupils will constrict because we don't need to see as much. In the lungs, beta 2, if you're running from a bear, you're going to want to breathe more, which means that you're going to want to dilate the muscles around the bronchioles. Beta 2 is an IPSP, which will allow you to constrict or to dilate those muscles and breathe better. And when you're resting, you don't need to breathe as much. So M1, muscarinic receptor, is an EPSP that will dilate those and make you able to, don't have to breathe in as much air. The heart, you're running from a bear, you need blood pumping, you need high blood pressure, you're trying to go, you need an EPSP, which is what beta 1 will do. It'll trigger an EPSP. And M2, if you're trying to rest, digest, you're trying to just rest, you're going to want to slow your heart rate. So IPSP, coming from the M2 receptor. And for blood vessels, you're trying to run, you're going to want high blood pressure so you can keep going. Alpha 1 is an EPSP, which will vasoconstrict and allow you to raise your blood pressure so that you can keep going. That's why the secondary receptors in the nervous system are so important. But there's also different things that can help. There's a certain drug called MAO, M-A-O. This makes it so that your body won't break down catecholamines, which is very beneficial if you're trying to create a sympathetic response in the nervous system. And then things like organophosphates, things that block, so we'll just put block acetylcholinesterase, So things that block acetylcholinesterase is something that breaks down acetylcholine in the synapses. If we're not breaking down acetylcholine, because the N2 receptors and the M receptors bind to acetylcholine, this will create a parasympathetic response because we are playing to the strengths of the parasympathetic nervous system.